Hello everyone, welcome to another video, and today's topic is going to be partial fraction decomposition. And this one should be relatively quick because this is probably the most robust and easy to remember part of this course. And it probably won't show up on FRQs if I'm honest, but just in case it does, we're going to go over it. And I'm going to talk about some abstract things before we go into talking about an example problem. But I'll show you the example problem first. So the example problem we're going with today is going to be 9 minus 9x divided by 2x squared plus 7x minus 4, the integral of that dx. So how are we going to solve this? Well, the first thing that we notice is that there's always going to be, when you're doing partial fraction decomposition, the numerator always has to have a degree of 0 or 1, which basically means that there's either 1x here or there's not. You can't have x squared, you can't have anything. You need to make sure that you have this at the very maximum. And you'll discover that if you have like something like 9 minus 9x cubed, and you try to do partial fraction decomposition, even if this is something crazy like 2x to the 7th, something larger than this, it still won't work. You have to have this to the first or 0th degree. So that being said, you'll notice that you have the second condition is that you have to have something that you can split apart here, specifically something like a polynomial. So here we have 2x squared plus 7x minus 4. So the first thing that you're going to want to do is split this up, right? And we can very quickly split this up. The top, I'm going to take the 9 out of the top and move it to the outside, because why not? And then we'll just have down here, we're going to split this up through polynomials. We can just say, what's it going to be? I'm going to say that this is going to be 2x minus 1, and then this will be x plus, minus 1 plus 4. Negative 1 times 4 is negative 4. 2 times 4 is 8x. Negative 1 times x is negative x. So 8 minus 1 is 7. And so that should give us that value 7 there, and then 2x times x is 2x squared. Cool. So we have this split up, and we have these two factors. So what does partial fraction decomposition tell us? Well, partial fraction decomposition essentially says this. If I have something, right, something with a numerator, if I have some numerator over two things, in this case 2x minus 1 times x plus 4, this is equal to some value a divided by 2x minus 1 plus some value b over x plus 4. And this is true for most of any problem where you have partial fraction decomposition. And the place that this comes from is something simple like this, is that you have that being true. And with that identity, what we can do is we're going to plug everything in. So some value a that we don't know over 2x minus 1 plus some value b over x plus 4 is equal to 1 minus x over both of those, over 2x squared plus 7x minus 4. But we're not going to do that, because what we're going to do is split them up firstly and multiply both sides by x plus 4. Well, if I multiply both sides by x plus 4 over x plus 4 cancels out, so that goes away. X plus 4 over x plus 4 cancels out, so that goes away. And then we end up with x plus 4 times a divided by 2x minus 1. Do the same thing with 2x minus 1, and we find that this cancels out, and then we get b times 2x minus 1. And now what we're going to do is we're going to create two scenarios where we can solve for a. So, in order to do that, we need to make b equal to 0 to solve for a, and a equal to 0 to solve for b. So, how are we going to do that? Well, simple. What we're going to do is say, how do we create the things in these parentheses in a way that equals 0? So if we plug in negative 4 here, negative 4 plus 4 is 0. So that means that a will be 0 so that we can solve for b. So if we plug in negative 4, negative 4 plus 4 times a is 0, so that goes away. And then negative 4 times 2 is negative 8, minus 1 is negative 9. So negative 9 times b equals 1 minus x. And if I, and x is going to be negative 4 again, so 1 plus 4, because it's minus 4, is 5. Cool. So we have negative 9 times b is equal to 5. So what we're going to do, we know that b then is going to have to be equal to 5 divided by negative 9. Cool. All right, so we have the value for b. Now let's get the value for a. One cool trick that I've learned that I'll teach you in a second is that b plus a is always going to be equal to 1. That's the thing that you can always do to check your work. And you'll see that in a second. So how do we set this equal to 0? Well, simple. We just multiply this by 1/2. 1/2 times 2 is 1. 1 minus 1 is 0. All right, cool. So we do that. B becomes 0. 1/2 plus 4 equals 4.5. 4.5 is equal to, well, 1 minus 1/2 is 1/2. So 4.5, 1/2 divided by 4.5, that's essentially 1/2. Sorry if I'm going a bit fast, but basically if you solve for this, you'll get 1/2. You'll get a, you'll get 4.5, and then what you do is you divide both sides by 4.5, so 1 over 4.5, wouldn't you know it, this times this, you get 1 over 9. And this plus that is not 1. Interesting. So that means that there's something definitely wrong here. Let me go back and solve for a. But you get the gist of it. In this situation, you'd have 2x minus 1. Sorry, you get 1/2. You get minus 4. Nope, this is 1/2, right? So 1/2, you get 4.5 times a is equal to 1 minus 1/2. You get 1/2. You divide both sides by 4.5, or 9 over 2. Multiply both sides by 2 over 9, you get 2 over 9. 2's cancel out, you get 1 over 9. So maybe I did the b incorrectly, but most of the time, these will add up to create 1. Sorry about that. So we have this value for a, and have this value for b, and so what we're going to do now is just go on ahead and plug these into our original problem. So we go and plug them in a way that's split. So if you remember correctly, a was over x plus 4, right? Yes. And b was over 2x minus 1. Cool, we have both of those. And now what we do is we just plug them in. A is 1/9, so we get 1 over 9 times that. And then we get b, which is 5, we get the minus sign, 9 times that. What we can do now is a, take out the 1/9, because if we take out the 1/9 from both, because there's a 1/9 here, 1 over 9, and 1/9 here, that cancels out with this 9. Cool, this 9 up here that we established, the one we took at the beginning, because of 9 over 9, that goes away. And now we end up with this integral right here. And to simplify it, I'm just going to break these up. So these are now 2 integrals. Sorry for my bad handwriting, but you have this integral minus this integral here, and you can go ahead and just solve those simply, because this is just a natural log problem. And the way we solve natural log problems is 1 over whatever this value is. So natural log of the absolute value of what this is. And the 3 steps to solving these natural log problems are, you have the numerator, there's no number in the numerator. You have the denominator, and is there a coefficient of x? The answer here is no. So right now we just do natural log of the absolute value of x plus 4. Cool. So right here we have a minus sign. So minus, is there a numerator here? 5, yes. So that means that we move that to the outside. Minus 5, oh frig. Minus 5 times 1 over blah, blah, blah. So that means that this would be on the outside of the natural log. Except one last thing, don't forget, we have a coefficient here also for the x. And believe it or not, what this is going to lead us to is we move the we make this 1/2. So you take the reciprocal of the coefficient of the x, and you would solve that ultimately by use substitution. But instead of doing use substitution and all that work, you just say this, we're going to move it outside and make it a reciprocal because it's on the bottom of the fraction. So what we'll do is a quick trick is just have any number that's on top divided by the coefficient of x. So we have 5 over 2 natural log of the absolute value of whatever's down here, including the coefficient, plus c. And excuse my bad handwriting again. All right, so I hope that helped. Sorry again for my terrible ability to explain and write, but this is going to be partial fraction decomposition decomposed.